In this video, we are going to talk about the basic concept of measure of variation. So measure of variation includes the range, variance, and standard deviation. Let's start with the range. So what is the range? The range of a data set is the difference between the maximum and the minimum entry in the set. To find the range, the data must be quantitative. So the range, let me give you the formula. The range is equals to the maximum entry minus the minimum entry. So the data must be quantitative. So I have a data set for you. So in this data set, there are 10 math placement test scores, right? So when you go to college, you have to take a placement test. And then after the test, the math department is going to use your score to place you on a certain position, right? So if you get this score, you can start on calculus. If you get such score, you have to start in pre-calculus. If you get a lower score, you might have to start in algebra, so on and so forth. Okay, so we have 10 placement test scores. I want to find the range. So what is the maximum entry? So the range, the maximum entry is 95, right? So that is the highest score. And then what about the lower score? The lower score is 58. So you have 95 minus 58. So that is equals to the range. So what is the range represent? Think about it. What is range represent? The range represents the distance between the lowest score and the highest score. So since 95 minus 58 is equals to 37, so the lowest score and the highest score, right? There is a lower score person, there is a higher score person. The distance between them is equals to 37. So if the highest is 100, the lowest is 90, the difference between the maximum and the minimum is a 10. So if the range is large, we know that this may be the data, they are so spread out, right? But there is a disadvantage. Range is easy to calculate, but range uses only two entries from the data set, right? The max and the min. We are trying to measure the variation that use all entries in the data set. So when we talk about variation, I want to consider every single data entry. Two measures of variation that uses all entries in the data sets are variance and standard deviation. We are going to talk about that in this video. So in variance, we want to compare each entry in the data set with the average value of the data. So that looks like a lot to take, right? That sounds a lot to take. So what is variation? Let's take a look at this word variation, and then we will go back to the concept of variance. So variation basically is, so every time you take a test in any class, psychology, English, math, biology, chemistry, whatever class that is, every time the whole class finish a test, the professor will announce, okay, this is the average score. So let's say the average score is 80, right? So let's say my score is 90, then okay, I am above average. Let's say your score is 60, then you are below average. Let's say my friend's score is exactly 80, then my friend is exactly on average. So that's how we compare ourselves to the whole class. So this is what deviation is. Deviation is you want to take your score to subtract the class average. So you are taking your score x minus the class average, subtract the mean. So if you are above average, so that means your score is greater than the mean, right? Then variation is positive. Zero variation means you are exactly on average. And then negative deviation means you are below average, right? So since we talk about the mean, then we have to find the mean. So how do you find the mean? The mean is equals to, let's use a different color for that. The mean is equals to the sum of all the data subdivided by 10 entries, right? So 58 plus 64 plus 74 plus 79, and then we keep going until we reach to 95 divided by 10. So the sum, that is equals to 796 divided by 10. So the mean is equals to 79.6. What does that mean? The mean is equals to 79.6. The average score is 79.6. So that means if you select a student randomly, my best guess is that that student got 79.6 points on the placement test. All right, so that is like a long-term average. So if you select someone randomly in a classroom. So let's say you just took a test in your chemistry class, the average is 80. So that means if I select a student randomly in your class, my best guess is that student has 80 points on the test. So that's how we interpret the mean, right? So on average, people get that many points on the test. So now I am going to make a comparison. I am going to compare every single data entry to the mean. So that brings you to the first table on the left. So on the left, do you see that we have two columns, right? We have basically two I didn't use 10 rows because I want to make the table more compact. So I use a red line to divide the big table. So on the left side, we have two columns, right? One for score and then one for deviation. And then deviation is equals to score minus the mean. And then let me go back to correct this real quick because I don't think this word is right. It's not variation. So I should use the word deviation. So deviation is equals to x subtract the mean. So you compare your score to the whole class. So the first score is 58, and then I take 58 subtract 79.6, I get a negative. The next score is 64. You take 64 minus the mean, 74 minus the mean, 79 minus the mean, so on and so forth, right? So every time you take a score, subtract the mean, you get a deviation. Some deviations are negative, some are positive, and some are zero, right? That is totally normal. If someone got exactly 79.6 points on the placement test, then that person's deviation is equals to 0. And then take a look. Negative deviation means what? That person is below average. Positive deviation means that person is above average. And then 0 deviation means that person is exactly on average, right? So negative means below, positive means above, and then 0 means exactly on average. All right, and then now, so here is what I'm trying to do. So we have a deviation, right? So everyone has a deviation. What we want to do is, okay, so before I say that, we go back to the mean. What did we do? We add up everybody's score divided by 10 to find the average score, right? All right, so for deviation, using the concept of finding the mean, I can find the average deviation, right? So let me write this down. Average deviation. How do we find this? So what we have to do is, I am going to take everybody's deviation, add them up, I will get a sum, and then I will take that sum divided by 10. So the first deviation is negative 21.6, and then we add a 15.6. So add a negative means you subtract, right? 15.6 and then 5.6 minus 0.6 and then plus. So because 0.4 is plus, and then we 2.4, 2.4, and then we go all the way to 15.4, and then divided by, we have 10 scores. So the average deviation is equals to, I'll just write the whole thing. So the average deviation is equals to 0. So because why is this a 0? Because the sum is equals to 0. So if you add up all this data, so if you add up this and then this, you will get a sum equals to 0, and then 0 divided by 10 is equals to 0. All right, so the average deviation is 0. Is this only for this data? If I switch the data to something else, the sum is not going to be equal to 0. So let me tell you, it doesn't matter what data you use. I don't care how big or how small the data is. The sum of deviation is always equals to 0. You take the sum divided by the size of the data, you will always get a 0. So the average deviation is always equals to 0, because there is no way to avoid having a sum of 0. There is no way to avoid that. The sum is always equals to 0. All right, and then what do we do? The sum is always equals to 0. So the 0 divided by any number is always equals to 0. What I am trying to do is, I want to avoid getting a 0. In order to avoid getting a 0, you have to get rid of the negative. The negative, do you see the negative deviations? they are the enemies that makes our sum equals to 0. I want to avoid having negative. There are two methods to do it. Either you square the negative or you take the absolute value. So this one, if you are trying to get rid of the negative, so let's say for square, so let's say I have a deviation of -2, you square that, that becomes positive, right? And then the square of 0 is positive, the square of positive is positive. Another way to do this is absolute value. Absolute value. So this is absolute value. The benefit is if you take the absolute value of negative, you can get away the negative. Absolute value of positive is positive. Absolute value of 0 is equals to 0. However, due to the mathematics, I will not take the absolute value. I will use the square only. So what I am trying to do is, do you see the two big circles on the table? I am going to square every single one of them. All right, so I am going to square every single one of them. That leads you to the table below that. So do you see that I have 10 score, I have 10 rows, and then I copy and paste the positive and negative deviation in the second column, and then in the third column, I type deviation square. So deviation square means I square every single one of them. So after you square the negative, the negative 21.6, the deviation square is no longer 0. But since we take the square, we have to square every single one of them. So in column 3, do you see that we are no longer having any negative? Alright, so since we are no longer having any negative, the sum is not going to be equal to 0. So for the deviation square, you add them up, you get a sum of 1204.4. When you take that divided by 10, you get a 120.44. So that is the average deviation. All right, so it is no longer 0. So now we can interpret that, but before we interpret that, that creates another problem. The problem is, what is the unit? The unit is point, right? So the unit of score is point, right? When you get a score 80, you get 80 points, right? But what about you square the points? Then you get a point square, right? What is point square? Have you heard about that before? Let's say, make this easier. Let's say money, dollar. When you square that, you have dollar square. What is dollar square? Is that means I have a lot of money? The answer is no. Dollar square, point square, they makes no sense. But since that makes no sense, why do we square them? The thing is, if you don't square them, you will start with a 0. Okay, so let's square them. At least I can get away from the 0. Since you square them, yes, you get away from the 0, but in the meantime, you square the unit, so the result makes no sense. Alright, so there is only one way to get rid of the square, which is taking the square root. So when we take the square root, we have a standard deviation. So standard deviation, let me use another color for that. Standard deviation is taking the square root of 120.44. So this one, we round this up to 10.97, or we are going to round this up to 11 point for simplicity, because I will be using the 11. Alright, so since we take the square root of that, the point square is off instantly. So now the unit is 11 point. Okay, so the unit is 11 point. So what does that mean? We have the mean equals to, so we have the mean equals to 79.6, and then the average deviation is equals to 120.44 point square, and then the standard deviation, I am going to use SD for short, is equals to 11. What does that mean? This is how we interpret this. So on average, if you take a student out randomly, my best guess is the student has 79.6 points on the test. But this is only a point estimate. What is point estimate? Point estimate means you are using one number to estimate another number. Let's write this down. Point estimate. is a very important word in statistics. You are using one number to guess another number, but we want to be more precise than that. So in order to be more precise or more flexible, I will be using the 79.6 plus or minus the standard deviation. So let me move these two pictures down a little bit so I can get more space to do the writing. Okay, so plus or minus 11, that means you have 79.6 plus 11. That is equals to 90.6. And then you take 79.6 minus 11, that equals to 68.6. So this creates an interval estimate, 68.6 comma 90.6. So this is called an interval estimate. Why do we have to do this? Because I want to be more precise. So if you take a student out randomly, my best guess is this student score is somewhere between 68.6 and 90.6 points. It's somewhere between two numbers. It's more flexible, right? So let me ask you a question. How much time do you spend to travel to school, from home to school? How much time do you spend? You don't say, all right, I spent 20 minutes, right? You don't say this. You say, all right, on average, I spend around 15 to 25 minutes to travel to school. Because you want to be flexible. You don't want to be too exact, right? So let's say you apply for a job. They don't say we pay $18 per hour. No, they don't say that. They want to be more flexible. They will say, let's say I pay you between $16 to $20 per hour, depending on your experience. If they say 18, if you have a lot of experience, they will still pay you 18. If you have no experience, they pay you 18. That is not fair, right? Okay, all right, let's take care of that. I'm going to make an interval between 16 and 20. So now, as long as the number I give you is between 16 and 20, then I am fair, right? So that is the advantage of using interval estimate. You want to be more flexible. When you try to make a guess, you want to be precise. You want to capture more numbers. So as long as I give you a number is between the lower limit, so this is called the lower limit, and this is called the upper limit, then that will be better than giving you a point estimate. All right. So now, we have the population variance, the method that I just did, the average deviation, the 120.44 is called population variance. The first screenshot on the left, population variance. So population variance of a population data set of n entry, capital N, is population variance equals to sigma squares. So this is a Greek letter, is called sigma. Sigma square stands for population variance. In statistics, we will be using this word over and over again in every single stats class. Is equals to the sum of x. X means a data entry. Subtract the mu. Mu means the mean. So this is a Greek letter mu, mu, that stands for mean. Subtract the mean, square the result. So when you square, x minus mu is the deviation, right? You square that, you avoid all the negative, and then divided by the capital N. In our case, we divided by 10. So we do that for every single data, add up the result, then we get a population variance. So population variance, the problem is the unit is being square. All right, so to get rid of the unit square, we take the square root of that. That is called standard deviation. I usually call that SD, which is sigma, is always the square root of variance. When we talk about standard deviation, it's always the square root of variance. But in statistics, we talk about population, we talk about sample. So we have one set of formula for population and one set of formula for sample. So to give you a better comparison, I have a picture right there. So orange and green, one for population and one for sample. They are pretty much the same, right? So the only difference is when you use sample, so this is x bar. It's called x bar. X bar means average. In statistics, every time you put a bar on top of a variable, that stands for average. And for the sample variance, the s square in the denominator, we have n minus 1, right? So n minus 1, why do we do a n minus 1? So here is why. So sample variance is an estimation of population variance, right? Because sample is an estimation of the population. So you have a population, you get a piece of that, you have a sample. So that means sample is only an estimation of the population because that is taken from the population. You take a small piece from a big piece and then using that small piece to study the behavior of the big piece. So the small is an estimation of the big, right? So dividing by n minus 1 gives the best estimate. Again, best estimate of the population variance. An easier way to think about this is subtracting 1 from the sample makes the sample variance less accurate compared to the population variance if you do a n minus 1. So this is how I convince myself. All right, so as long as I is less accurate, right? All right, so why don't we take the n minus 1? So that stands for less accurate. And then the standard deviation is always the square root of the variance. Whatever the variance is, I take the square root of that, I get my standard deviation. The reason of taking a square root is because I want to get rid of the unit square. All right, so that is the basic concept of range, mean, variance, and standard deviation. So in the next part of the video, I will show you an actual example. So I see you over there. Before I sign out, if you think my video is helpful, please subscribe, like, share this out for me. I appreciate your help really, really much. I see you all in the next one.